Hello everyone, welcome back to my channel. Hi, I'm Mathematics. Today we have very interesting exponential equation 5 to the x equal to x, and we need to find our x. If you have your solution, your answer, you can also write your solution down into the comment section, and then we will check your answer, so it will be really interesting. So first of all, how can we solve this question? Let's apply nature log on both sides. Let's do this right now. So first of all, nature log on the left side, so we have nature log 5 to the x equal to nature log of x. And right now, if you look closely on the left side, we have really interesting expression because we can apply this property, this really basic property. So when we have nature log of a, right here we have power b, so this b can be easily be written right here. So as a result, we have b times nature log a. So right now, let's do the same thing right here. So this x will come down right here. So as a result, what do we have? X times nature log 5 equal to nature log x. Right now, let's try to group our constant on the right side or the left side, doesn't matter, and our variables on the left side. For example, doesn't matter the side, but let's group constant and variables. For this, let's divide both sides by x. When we divide it, so we divide both sides by x. As a result, what do we have? We have on the left side x times nature log 5. We're gonna divide by x equal to nature log x. We're gonna divide by x, and from here we can easily cancel this x, okay? And as a result, what do we have? Nature log x over x equal to 5. Let's change position a little bit. We can easily do this because we have all the time equal sign. So nature log x over x equal to nature log 5. And right now we can easily say that we split it by variables on the left side and our constant on the right side. But how can we find our x? Because x is inside this nature log function and x is our denominator. It's really great moment right now because a lot of students don't know how can we find from here our x. And the extremely important thing for us is to know about Lambert W function. This function looks like that. For example, when we have expression looks like that, a times e to the power a, when we apply Lambert W function to this expression, as a result, this is equal to a. Okay, and a is like wherever we want expression, doesn't matter. For example, we are talking about Lambert W function of 5 times e to the power of 5. Okay, and this is equal to only 5, yeah? When we're talking about Lambert W function of this expression, the main thing we need to have e, okay, obviously we need to have e, and we need to have the same values on the left side and as a power of e, okay. And right now let's try to create this structure on the left side. First of all, we need to create e. How can we do this? This x we can easily create in terms of e, we can easily rewrite it in terms of e, yeah? This x is equal to e to the power nature log x, okay? This is extremely important substitution because instead of this x, we're gonna plug in e to the power nature log x. So as a result, what do we have? Nature log x. We're gonna divide it by e to the power nature log x, e to the power nature log x equal to nature log 5. Okay, right now let's write this expression, let's bring this from our denominator to our numerator, but don't forget about that thing that we need to put minus right here, because when we have 1 over a, we need to write a to the power minus 1 if we bring it from our denominator to our numerator, alright? So let's do this. So as a result, we have nature log x times e to the power minus nature log x, because we write it in our numerator, equal to nature log 5. Right now, let's look closely. It looks like we have a great expression to apply Lambert W function. We have e, and we need to have e right here to apply Lambert W function. We have nature log x, and we have nature log x right here. It looks like that, but we have minus right here. So, okay, so we are talking about this not the same expressions, but we need to have the same. We need to have a and a. And right now, there's like a really interesting tricky move. We're gonna multiply both sides by minus 1, and it helps us a lot because when we multiply both sides by minus 1, when we multiply it or divide, doesn't matter, when we do this, as a result we have minus in the beginning, so minus nature log x times e to the power minus nature log x equal to minus nature log 5. And a lot of students ask me why I multiplied both sides by minus 1, and right now let's look closely. Minus nature log x and minus nature log x right here. So for example, this is our a, and this is also our a. So we are talking about a times e to the power a, the expression of the structure that we need to create, like to apply Lambert W function to this, okay? And right now we can easily do this because we have the same minus nature log x, we have e, and we have the same power of this e, we have minus nature log x. So right now let's apply Lambert W function. Let's see what will happen. So Lambert W function of minus nature log x times e to the power minus nature log x equal to, don't forget about right side, so Lambert W function of minus natural log 5. All right. So right now, Lambert W function of this expression, so minus natural log x right here, minus natural log x, and we have e, yeah? This expression is equal to only our a, but a equal to minus natural log x. So on the left side, we have only minus natural log x on the left side, and on the right side, we have Lambert W function of minus natural log 5. Really great. And right now let's find our x, because don't be scared about this right side. This is our constant, this is also a constant. We are talking about Lambert W function of a constant, which is also like a constant. So right now let's find our x from here. First of all, let's multiply both sides by -1, because we have right here we have natural log of minus natural log x, yeah? When we multiply it, we have natural log x, only natural log x on the left side, equal to minus Lambert W function of minus natural log 5. What we're gonna do next? The next thing is very tricky move, because instead of this natural log x, we can easily so the main idea, we need to find from here, we need to find our x. How can we do this? There's like one really interesting move. Let's look closely right here. When we create base of e on both sides, so when we write base of e on the left side of this natural log x, and when we write base of e on the right side of this expression, minus Lambert W function of minus natural log 5, it changed nothing. Obviously, it changed nothing for us. And if you look closely right now, e to the power natural log x, if you look closely right here, e to the power natural log x equal to x, okay? So we're talking about x on the left side. So x equal to this expression, this is a constant, so doesn't matter. So e to the power minus Lambert W function of minus natural log 5. We can easily simplify it. We can do one really tricky move from here. We can easily write it in our denominator, because we have negative power. So as a result, equal to x equal to 1 over e to the power Lambert W function of minus natural log 5. And this looks like our answer to this question. But I made a quick research about this root, because I was wondering about this value x approximately equal, like in terms of real numbers. I was wondering about this answer, and when I plug in this Lambert W function of minus natural log 5, so let's split it, okay? Lambert W function, I was wondering about this Lambert W function of minus natural log 5, 5, yeah, minus natural log 5, and when I plug in this expression in my scientific calculator real quick, I'm plugging this expression, I found that this expression does not exist, okay? Does not exist. So it means that this is our complex value, okay? Complex value. This is our complex value. So when we are talking about Lambert W function of minus natural log 5 is complex value, so it means that this x is complex. This x is complex root. And I was wondering about geometrical interpretation, because I was thinking about this root, okay? Maybe we're talking about complex root, so it means that our function does not intersect. So we have 5 to the x equal to x. So if we're talking about geometrical interpretation, we are talking about 5 to the x. This is our exponential function. Yeah, 5 to the x. This is our exponential function. And if we're talking about y equal to x, this is our like linear function, or something like that. And if we look closely, maybe we can get right here one point of intersection, but I plug in this question in a internet library. You can easily see this. Interpretation right now. So it means that these both graphs, so this is our 5 to the x, and this is our x, doesn't intersect with each other. So it tells us a lot, okay? This is our complex unit, this is our complex root, we find it, and as a proof, we can easily see that this graph does not intersect with each other, like in terms of infinity, and these graphs does not intersect with each other, which is really important moment right now. So we can easily say that our root is complex, and these both graph, in terms of like geometry, this graph does not intersect with each other. So complex root and this graph does not intersect. It means that we solved this question absolutely correct. So let's write our final answer to this question. So x equal to 1 over e to the power Lambert W function of minus natural log 5. This is our answer to this question, and a quick research about this root, okay? And this is my explanation, this is my solution to this challenge. Complex root, complex solution, and both graph does not intersect with each other, and it's it's really great. Both graphs does not intersect with each other. Right here and right here we don't have point of intersection. Even right here we don't have point of intersection. Even like this is a closer like distance to these both graphs. Okay, graphs does not intersect with each other, and these are our complex root. This is my solution to this question. I really hope you learned something new. I really hope you understand something new. You can also write a question down into the comment section, write your notes down into the comment section. It will be really interesting to read about it. You can also write your solution down into the comment section. And thank you for your time, thank you for your support. Wish you all the best. Thank you everyone for your kind comments, for your likes, for your dislikes. It's really important. It's extremely important for this type of content. And thank you everyone. Wish you all the best in your life. See you in the next videos and have a great day.